So this is f of x is equal to x minus 1 plus x plus 2. Now the modulus, you pick the first modulus. By definition of the modulus, we say that this modulus is equal to everything that is inside, provided it is positive. If it is negative, you multiply it by a negative so you can make it positive. So if it is negative, then I will multiply it by another negative so that I make it positive. Remember, we said that the modulus of x is x if x is positive. And if x is negative, to make it positive, you multiply it by a negative. That is, if it is negative. For example, if I give you 2, 2 is positive. So what you put on the right is not this and that. You just pick 1. So since 2 is positive, it will be equal to 2. That's the meaning of this definition here. If I take negative 3, because the number is less than 0, I'm going to multiply it by a negative, and then I bring the number so that my final result will be a positive number. So you won't have to have 2 at each time. What will determine what you should have is the sign of the number inside the modulus. So now, because x is a variable, we are saying the modulus of x minus 1 is going to remain x minus 1 if after we use the x, what we get is positive, meaning the whole x minus 1 is a positive thing, then it will remain as it is. But if it is giving us a negative, for example, it's giving us negative 3, we'll have to multiply it by another negative to make it positive. That's the purpose of this negative, which is waiting outside here. But now, we need to simplify these inequalities here. You simplify each inequality so that you can have the pure interval of x and not of an equation. So this thing is going to be, these will remain as they are, x minus 1. Our calculations now are based on x minus 1 greater or equal to 0. What is the value of x here? So the range of x is, you take this number the other side, it becomes x greater or equal to positive 1. This is what you get now, and put in front here, x greater or equal to 1. You copy the next thing here as you are expanding it. Negative times x is negative x. Negative times negative 1 is positive 1. When the interval, now you solve the interval, x minus 1 is less than 0. So you take this one the other side, x is less than 1. Meaning that in this interval, x is less than 1. So we are done with the first piece. Is it okay?
Yeah,
Yes,
okay.
it's fine.
Okay. Then we get the second piece. X plus 2 is equal to, again, if it is positive after using x, then you keep it as it is, provided it's positive, bigger than 0. But in case it is negative, you must keep a negative outside to multiply the thing that you get if it will come out negative. Meaning if x plus 2 is less than 0. Again, we have a task of calculating these. You simplify them. So x plus 2 greater or equal to 0. You take this to the other side. You get x greater or equal to negative 2. So what we have now on the first piece is that x plus 2 only when x is greater or equal to negative 2. Then you come down and expand this negative x minus 2. So you put it here, negative x minus 2. When x plus 2 is less than 0, take this the other side. You get x less than negative 2. So when x is less than negative 2. That's how we define the second piece. Are the pieces okay? Yes?
That one is supposed to be positive. The last one, x, negative 2, x is less than negative 2. Supposed not to be positive because you multiply with negative there.
Where do you multiply with negative?
Where is x negative?
The negative
open
is
brackets,
here.
X plus.
The negative is only here. There's no negative here.
Okay.
You only put a negative to the function. So we are saying if x is less than 0, you multiply it by a negative. This one is just giving us a condition when we should multiply by a negative. So it's not getting affected by the sign. Okay. You can move. You guys, are you okay? Want to move?
Sir, over the last one, the sign, it won't change the moment we divide by a negative 1, since x is having a negative.
The inequality you solve is this inequality here, and not this one. Where there is a negative, you just expand.
All right, thank you.
Yes. Then, now that we have redefined both pieces, we want to put them together. So how do I put them together? You pick the numbers that we have, the critical numbers that we have. We have 1 and negative 2. So you put negative 2, you also put 1. Draw a line the same way we make a table. Draw another line there. This time around, you are not picking a number in between the intervals. No. What you are doing is you want to determine the nature of each piece in the given interval. Remember here, x is less than negative 2. I mean, x is bigger than negative 2, but less than 1. In the other piece here, we are saying x is bigger than 1. Okay? And the other one here, x is less than negative 2. Now we have two functions. We have this modulus there and this modulus here, defined in these two pieces each. So if I want, I can put x minus 1 here in its modulus and say, what is the piece? Since each modulus has two pieces, what piece do I put for x minus 1 when x is less than 2? So what piece do you choose? Because the modulus of x minus 1 has two pieces. It has x minus 1 when x is bigger than 1. It has negative x plus 1 when x is less than 1. Now, where does negative 2 lie? Is negative 2 bigger than 1 or less than 1? So negative 2 is less than 1, meaning that in the piece where x must be less than negative 2, we'll pick the piece where negative x, this piece where x is less than 1. So what we'll do is we'll pick negative x plus 1 for this function, which has two pieces We'll pick the one where x is less than 1. Next, again, we want now where x is less than -1 itself. Between -2 and 1, we have again direct now x is less than 1. So it still remains the same in this piece. What about when x is bigger than 1? Of course, it is here where x is bigger than 1. So it will be x
I have a
minus
question.
1. Please ask.
What the modulus function that in there? What can happen? Can we still get this answer that you have?
If you do what?
If you replace -2, like since we are saying x is less than -2, we replace it in x minus 1, the modulus. What would happen?
You get, no, you don't replace. If you replace, you're looking for a sign, but you're not looking for signs here. We're looking for the function defined in that piece, depending on the interval that we have on the right.
So, sir, how are you? Why couldn't we get -x minus 2 then instead of -x plus 1? How are you doing it?
No, we are still dealing with this piece here. We haven't gone to the second one. Now we are going to the second one. We now get x plus 2. So now we got x plus 2. What is x plus 2 when x is less than -2?
It's
It
negative
is
x -2.
-2. What is the modulus of x plus 2 when x is bigger than -2 but less than 1? Meaning you have entered that region now. X is bigger than -2. So this function is x plus 2. It remains x plus 2 even when x is bigger than 1, because 1 is even bigger than -2. So you still have x plus 2.
So for the middle part where you say x is the x plus 2, there, how did you find it? Like, can you explain?
What interval are we dealing with? The interval is x greater or equal to -2, which is this interval here. From here, going this side. The function remains fixed, x plus 2. X plus 2.
Okay.
Going to the right. So that's how we form a table. So I'm going through this again. So how do you form a table? You pick each piece at a time. After you define them, you keep the important intervals. X greater or equal to 1, x less than 1. You go to x greater or equal to -2 and x less than 2. Because you are picking -2 and 1. Now that I'm picking -2 and 1, this is -2 here. This is 1. You go to the first function, the modulus of x minus 1. How is it defined? It is defined as x minus 1 if x is bigger than 1. Now, is -2 bigger than 1? -2 is less than 1. So meaning for the function x minus 1 modulus, we are talking about this interval where x is less than 1. So we'll pick the negative x plus 1 in the interval which is less than -2. Even in the interval between -2 and 1, x is still less than 1. So we'll pick the same piece, -x plus 1, for this modulus. But once we go beyond 1, we'll now go and start using the top one because it's the one that is defined when x is bigger than 1. So I'll have that arrangement there. Then I'll go down to x plus 2. X plus 2 in the modulus is defined as negative x minus 2 if x is less than 2, is less than negative 2. And here's what we have, x is less than negative 2. So we pick this definition of this function. Then when x is bigger than negative 2, because numbers that are in between negative 2 and 1, these numbers are bigger than negative 2. So when x is bigger than negative 2, which function do you use for the modulus of x plus 2? You use x plus 2 itself. That's why we got it here. You go to when x is bigger than 1. I mean, 1 is even bigger than negative 2. So automatically, we use this piece here because it's the one which has the required interval. That's why it has appeared again. So after you define them like this, you remember that actually these pieces are being added to give us the whole f. So we must add them to get f. So I want to finish this thing on this same board.
Sir, sorry for taking you back. Can you just repeat on the first equation how you did it?
On the first line, this one.
Yes, sir.
Okay. So what you have is this function x minus 1 modulus defined in 2 pieces. The first piece is this one, x minus 1 when x is bigger than 1. So you come to your numbers. Where do I find x bigger than 1? Between negative 2 and 1. So it's this interval which you have said x bigger than 1. That's where that function is defined. So you pick that number, x minus 1, put it in that interval. When x is less than 1, x is less than 1 here, x is less than 1. You pick that piece, put it here. As you go to your left, x is still less than 1 because I talk about negative 2. Negative 2 is less than 1. So x is still less than 1. Any number that is less than negative 2 is less than 1. So when we come back to these 2 pieces, you can't pick x minus 1 where x is bigger than 1 if you are dealing with negative 2. So you pick where x is less than 1, which is negative x plus 1. This one here. You follow it up, the x plus 2. When it is less than, when x is less than negative 2, you use this definition, which is here. But when x is bigger than negative 2, you use the top one where x is bigger than negative 2, which is this one here, x plus 2. If you talk about 1, 1 is even bigger than negative 2. So automatically it will be x plus 2. Then now, what next? So you say, okay, now that I've defined them in this way, then, so I use this space instead of going next and coming back. So now you say f of x is equal to, in each interval, we'll be adding. In the interval x less than negative 2, how many functions do we have? We have 2. When x is less than negative 2, we have this one and this one. So add them. Negative x plus 1 minus x minus 2. This is only for x less than negative 2. Only for this interval from here going this side. For the middle interval, for the middle interval now here, we have this one and this one. So we have negative x plus 1 plus x plus 2 for negative 2 less than x less than 1. When x is bigger than 1, we have x minus 1 and x plus 2. So we'll have x minus 1 plus x plus 2 when x is bigger than 1. Now remember that here we have greater or equal to, so we'll put the equal to there. Here we also had a greater or equal to, so we put the equal to here. So we have defined now our function. What remains is to simplify it. So we simplify. Negative x minus x, we get negative 2x. Positive 1 minus 2, we get minus 1 when x is less than negative 2. For the middle one, negative x plus x, 0. 1 plus 2, 3. When negative 2 is less or equal to x, less than 1. Then x plus x, you get 2x. Negative 1 plus 2, you get positive 1 when x is greater or equal to 1. We now have a complete f of x. This is the function that we're going to sketch in those intervals. Is the function okay?
Yes, sir. Sir, there is no other method where you can find this function apart from using the table. There's no other method?
There's no other method.
Okay.
And if there is, then it's the hardest.
It is the hardest.
Yeah, because this one is the simplest.
Okay.
Okay. Let's now sketch it. So to sketch, we count. How many intervals do we have? 3 intervals. So we start with the top one, when x is less than negative 2. So we put negative 2 here. Pick the very negative. Now we have f of x is equal to, f of x is equal to negative 2x minus 1. For that interval which you are dealing with, negative 2x minus 1. Remember, x is less than negative 2, meaning it does not include negative 2. But you use negative 2 to get the boundary, to get a starting point. So you substitute negative 2 in f. What is f of negative 2? It is negative 2 by negative 2, where there is x minus 1. Negative 2 multiplied by negative 2 is positive 4. Minus 1, 3. Now we have negative 2, 3. So we go to 3 and put an open point. So it's an open hole. An open hole because it's not included. The only numbers allowed here are the numbers less than 2. Say negative 3. You substitute negative 3, you get negative 2 minus 3 minus 1. This will be positive 6 minus 1, which is positive 5. So we have a point bigger, meaning that we have a line coming down. So it's not important to label the points that I get afterwards. All I want is the guidance. Do I go up or I come down? That's all you're asking for when you're substituting another number. So we are done with this interval. You go back and check. The next interval is 3, 4, 3, 4. So it is 3 for -2 less or equal to x less than 1. So when x is -2, f of -2, remember f of x is defined as 3 for the whole of this interval. So if I pick x is equal to -2, I will get 3. It's a constant function. So at -2, we get 3. So you go and close there, since we are getting that point. You get the last number, 1. F of 1 must give us 3. Though 1 is not included. So we'll open there. You can try a number in between there, even 0 must give us 3 because it's constant. So we'll have another straight line there. Then we got the last piece. F of x is equal to 2x plus 1. F of x is equal to 2x plus 1. Is it plus 1? Yes. When x is greater or equal to 1. So if we substitute 1, so what is f of 1? It will be 2 multiplied by 1 plus 1, which is 2 plus 1, which is 3. So at 1, we are getting 3. So we go and close there. I pick any other number, say 2. What is f of 2? F of 2, you substitute in here. So 2 multiplied by 2 plus 1. That is 4 plus 1, which is 5. 5 is bigger than 3. So we have a point somewhere there, meaning that the graph is going to go up. So this is what I call my equation, like that. So now the graph is complete. Are there questions to be asked?
Sir, I have a question.
Please ask.
When solving these equations, is it that which equations, like when sketching the graph, which equations are we supposed to use? The ones for the table or after we add them?
After you add them. So we use these. We use the simplified ones. That was 1. So after you add them, and this is the graph.
I have a question.
Please ask.
The numbers that you are using to replace in f of x, which numbers are they? Are they just any numbers, or you are getting them from somewhere?
They are n numbers, but guided. You pick a number that is less than -2 if you are dealing with the first piece. And you pick a number that is in between -2 and 1 if you are dealing with the second piece. And you pick a number bigger than 1 if you are dealing with the last piece. So you follow the intervals.
Okay, sir, thank you.
All right.
So I have a question as well.
Okay.
So I have a question as
Please ask.
I have a question as well. What if the equation apart from the moduluses, it has a +1 outside here. Does it mean that that +1 could have shifted the graph like we were doing yesterday?
Yes.
All right,
It could have
thank you.
shifted. All right. Hello?
Sorry, can you kindly explain how we're getting a straight line there?
How are getting all the straight lines?
The horizontal line, the straight line, the red line, how are we getting it?
We are told that f of x is equal to 3 for all the numbers from -2 to 1. So f of -2 is 3. F of -1 is 3. F of 0 is 3. F of half is 3. In short, if I put -1 here, it will give me a 3. If I put a 0, it will give me a 3. If I put a half, it will give me a 3. Then I connect them to a straight line. So when a function is constant, f of x is equal to 3. It means that any value of x that you take, you must get 3.
So I've got a question. Can't you use the operations like in that table where there are a lot of functions, like 2 functions? Now you use the
Hello?
So the class has ended what?
Yeah, it's ending here.
It's ending.
Yeah, you have.
So the recording.
I'll send.
Sir, I've got a question, sir.
Please ask.
Okay, I was asking, can't you use, instead of using those functions on the table for you to plot a graph, can't you use the signs? Yeah, can't you use the signs? Like you find any number less than -2, you find which side is lying. Which position is lying? Is it to the negative or to the positive? You put if it's positive, you put a positive. Then you use these signs to plot a graph. Can't you use that?
No. We can't use that because the danger is you get a negative here and a negative here. A negative here and a positive here. It's still positive here, positive there also. So if you only had signs, you wouldn't know that now it must go up or now it must go which way.
No, sir, I'm going to post the video on YouTube.
I'm going to send the video in the group as a link. Yes.
I wanted to ask, in this case, does the starting point concept apply, or is it that you're only looking at the lowest value and the biggest?
So we look at the lowest and biggest in each interval.
Okay.
Hello, sir. I've got a question. Another question.
Uh-huh.
Yes. So I was saying, can't you use the signs? You said no. Now, since you have already know the boundaries, like you have no -2 and another boundary +1. So since you already know the boundaries, can't you say, since this function is lying, saying the function is x is less than -2. So you know that all the values for x for this function, they are lying to the they are less than -2. So since you already know the boundaries, can't you plot using the signs?